think of Iceland, you probably picture, volcanoes, glaciers, maybe the northern lights. But what's really fascinating is happening right under their feet. There's an energy revolution going on, and today we're going to dig into Iceland's geothermal secret, a wild technology that's turning a huge climate problem into solid rock. I mean, just look at this. You've got ripe, juicy tomatoes growing all year long, right in the middle of the North Atlantic. It honestly feels like something out of a sci-fi movie. But nope, it's real life in Iceland. They use geothermal heat to warm their greenhouses, and it makes the impossible, well, possible. This is the postcard image of Iceland's green energy dream.
And this isn't just some small-scale experiment. Get this, a staggering 90% of all homes in Iceland are heated with geothermal energy. Just let that sink in for a second. 9 out of every 10 houses are kept warm by tapping directly into the Earth's core. It's a society that is literally built on the energy right beneath it.
So on the surface, it sounds absolutely perfect, right? A true geothermal utopia. But here's the twist. What if this clean, green energy isn't quite as spotless as it looks? What happens when there's an inconvenient truth hiding inside all that beautiful steam? So first, let's just dive into that dream a little more. How exactly did Iceland get so good at this? How did they manage to weave this incredible energy source into the very fabric of their country?
Well, you can't talk about geothermal in Iceland without mentioning the Blue Lagoon. It's one of the most famous spas on the planet, and guess what? It's literally created from the mineral-rich wastewater of a nearby power plant. They turned industrial runoff into a world-class luxury destination. It's the perfect symbol of this whole geothermal paradise idea.
Okay, but now it's time to peel back that curtain. Let's take a look at the not-so-clean secret that's been lurking behind all that steam.
So you look at a power plant like this one, Hellisheiði, and it looks totally pristine, right? Especially against that Icelandic landscape. But the data? Well, the data tells a very different story. This one plant was releasing thousands of tons of CO2 and hydrogen sulfide every year. Now, is it cleaner than a coal plant? Absolutely. But is it zero emission? Not even close. And that brings us to the really crucial question. If it's not just harmless water vapor, then what exactly is being pumped into the atmosphere?
Turns out, the steam that comes from deep within the Earth is mixed with a bunch of dissolved gases. The big one, of course, is carbon dioxide. But you also get a lot of hydrogen sulfide. That's what gives geothermal areas that distinct rotten egg smell. The problem is, these gases don't just condense back into water like the steam does, so they've always been this persistent, unwanted byproduct. So, Iceland had a problem on its hands. It was a bit of a stain on its pristine green reputation. But in classic Icelandic fashion, they didn't just try to manage the problem. They engineered a really radical solution. They thought, okay, instead of releasing the CO2, what if we could just trap it forever?
And that's where CarbFix comes in. The whole idea is kind of brilliant in its simplicity. They basically mimic a natural process, but they speed it up a lot. They capture the CO2, dissolve it in water, and then inject that water deep into a very specific type of rock. And the result? The CO2 literally turns into solid stone.
Okay, so here's how it works. Step 1, capture those unwanted gases right at the power plant. Step 2, dissolve them into huge amounts of water, basically creating this giant industrial-scale sparkling water. Step 3, pump that carbonated water deep underground, about 700 meters down, into porous basalt rock. And then, step 4, you just let nature do its thing. The acidic water reacts with the rock, and in less than 2 years, the CO2 is solid mineral locked away for good.
Now, here's the part that really changes the game. The cost. The entire process costs less than $25 per ton. Now, to put that in perspective, other carbon capture methods can easily cost over $100 a ton, sometimes way more. So this isn't just an incredible environmental breakthrough, it's an economic one. It actually makes capturing carbon affordable.
And this whole way of thinking, turning a problem into an asset, goes way beyond just CO2. It's become a core philosophy in Iceland that's transforming their entire industrial landscape into a model for a circular economy.
This has led to the creation of what they call resource parks. The concept is just genius. You build a whole cluster of different businesses right around a geothermal plant. Then, every single output from that plant, whether it's CO2, minerals, or just hot water, becomes a valuable input for another business next door. Absolutely nothing goes to waste.
And really, it all started right here, with the Svartsengi plant and its accidental, now super famous byproduct, the Blue Lagoon. That one success story proved that what one industry considers waste could literally be another industry's gold mine.
And check this out. At one point, the spa, which is just using the power plant's leftover water, was making 50% more money than the power plant itself. It's such a powerful lesson, right? Waste isn't actually waste if you're just clever enough to find a new use for it. And that innovation cycle is just picking up speed. The CO2 they capture, it's now being used to grow algae for high-end cosmetics, or it's turned into carbon-neutral e-methanol to fuel ships. The warm water discharge, perfect for farming salmon. Even the silica that's naturally in the water gets extracted and used in health supplements. It is an absolutely stunning, self-sustaining industrial loop. Now, all of this is incredibly impressive, but it does raise the billion-dollar question. Is this just some unique Icelandic miracle, or could it actually be a blueprint for the rest of the world?
Well, from a geology standpoint, the answer is a huge yes. That key ingredient, the reactive basalt rock, it's not unique to Iceland at all. In fact, it's all over the globe, covering huge areas of the continents and pretty much the entire ocean floor. The potential storage space is, frankly, enormous.
But, of course, it's never as simple as just having the right rocks. A big study looked at geothermal plants around the world and found, well, a mixed bag. The tech is a perfect fit for plants in places like the US, Kenya, and Japan. But for others, say in Italy or Turkey, their plants just aren't built on the right kind of geology. And in some places, the technology inside the power plant itself just isn't compatible.
So it really comes down to a recipe for success. You need 4 key ingredients. You need that reactive rock, you need a lot of water, you need a concentrated source of CO2 nearby, and you need the right kind of tech at the plant. If you can get all 4 of those things in one place, you can absolutely replicate Iceland's magic. So we end on this thought. Iceland took what could have been a real blemish on its green image and turned it into a permanent solution, literally locking their emissions away in stone. The geology is out there for others to do the same. The real question is, can the rest of the world find not just the right rocks, but also the will to follow their lead?